Hey students! Today I'm diving into the fascinating world of chromatography. Chromatography is a key technique used to separate pure substances from mixtures. It's essential in chemistry, biology, and even medicine. So, what exactly is chromatography? Imagine you have a mixture and you want to know what's inside. Chromatography helps by separating each component based on how they interact with two different phases. First, there's the stationary phase. This is usually a solid and doesn't move. Then we have the mobile phase. This can be a liquid or gas that flows through the stationary phase, carrying the mixture along with it. As the mobile phase moves, different substances in the mixture travel at different speeds. The ones that prefer the mobile phase move faster, while those that stick to the stationary phase move slower. Now let's talk about the main types of chromatography. First up, column chromatography. Here, the liquid passes through particles of solid packed in a tube. It's like pouring a liquid through a filter, but with much more precision. Next, we have thin layer chromatography, or TLC. This method is simple, rapid, and quite powerful for separating organic compounds. In TLC, the stationary phase is a thin layer of material like silica gel adhered to a plate. The mobile phase, usually a solvent, moves up the plate by capillary action. Here's how it works. You apply a spot of your sample near the bottom edge of the plate. Then, you place the bottom edge in a reservoir of solvent. As the solvent moves up the plate, it carries the sample with it. Once the solvent front reaches the top, you remove the plate and let it dry. To visualize the separated components, you might use ultraviolet light, iodine vapor, or a chemical spray. For example, 9-hydrin turns purple with amino acids. Each component moves at a specific rate, creating a unique pattern of spots. You can identify unknown components by comparing their movement, or RF values, with those of known standards. The RF value is the ratio of the distance a component travels to the distance the solvent travels. Under consistent conditions, each component's RF value remains the same, making it easy to identify. Thin layer chromatography can be done in one dimension or two. In two-dimensional TLC, you run the plate in one direction first, then rotate it 90 degrees and run it again. So there you have it. Chromatography is an invaluable tool for identifying and separating substances in a mixture. Whether you're working in a lab or studying for an exam, understanding these basics will give you a solid foundation. Thanks for tuning in. If you found this useful, don't forget to like, subscribe, and share with your friends. Happy studying!